Oh my God.
So we are starting with your homework, which I think most of you finished in class anyway, so let's just make sure you remember what you did. So for the first one, we did this in class. So remember, there's always a system for reading these graphs. You always talk about the x-axis. We talk about that one because that's the one we're controlling. That's the one that's going to determine what happens to the y-axis. So in this case, we're going to increase temperature and pressure. Then will, according to this graph, it also increases. I think we did this one together as well. So in this case, throughout the experiment, time was marching on and temperature stayed the same. So as time increased, temperature stayed the same. Who wants to try this one for me? Go ahead, Ethan.
As temperature increases, density decreases.
You got it. As temperature increases, I wrote goes down. I don't know why I didn't stick with decrease. Just so you know, either way, as long as you know what decrease means, you're good. Who wants this one? Go ahead, Blakely.
As volume increases, density decreases.
You got it. Volume increases, density goes down. Trinity, you want the next one?
As time increases, temperature increases.
You got it. And on the back, I know we did this first one together. So again, in this case, they're saying as depth increases, that's the one that they're controlling. Pressure increases, so depth goes first, pressure on the X, or sorry, pressure on the Y, and that's a going up line. We did that one together. Who wants to do the next one? Oh, well, I guess I did it. Depth goes on the X. Density goes on the Y. Which way does the line go? Up. And next one. Oh, I guess I did these ones too. So altitude, X, temperature, Y, and that's a down line. And then we got population, pollution, and an up line. Studying and a grade, and that's another up line. And then finally, what was it? Time and velocity, time, velocity, and a flat line. You guys good with that stuff? Okay, I figured as much. We'll use these over and over. We'll talk about them when we get to them. I just want to make sure you guys can read these graphs without numbers because the Regents loves them this year. So you got to be able to tell me what these graphs mean by just looking at them. We did rate of change yesterday. So we're going to start on density, which is actually page 14. But before we do that, oh, of course I forgot to hit record. No, I did hit record. Awesome. I did what I wanted to do. So you guys talked about density back when you were a little kid. And then you re-talked about it in 6th or 8th grade, I'm thinking. Anybody remember what density is or able to describe it? Oh no, I shot you all down by telling you your observations were wrong earlier, and now you won't talk to me?
You know, like the weight or mass.
So it's not the weight or mass, that is mass. But it has something to do with it. That's volume. So right off the bat, I'm sensing we might need to write in a few vocab words. So why don't you, in your packets, because I'm sensing we have just some confusion about some vocab words. So in this packet, way up here, so this is page 14 if you're not there already. On page 14, I think at the very, very, very top, we need to make sure you know a couple of vocab words. First of all, volume. Volume is the amount of space an object takes up. Or in other words, it's just how big it is. Like big, like size big. Here's an object. It's a block of wood. Do you guys remember how to calculate the volume of this? If you don't remember that one, add that. Volume equals length times width times height. That's the only one you need to remember. So I know back in some math class, you had to learn how to calculate the volume of a sphere. or the volume of a cylinder or a cone. We're not doing any of that. The only thing we'll ever have to calculate the volume of is a block. And that is one of the other formulas that's not in your reference table. So that one you do have to memorize. I think most of you already have that memorized. So that's volume. Does anybody know what mass actually is? If I ask, what's your mass? What's it measuring? It is measuring your weight. And what is your weight though? That how much you weigh, right? It's the amount of matter in an object. So mass is the amount of matter in an object. And then what density? I know you guys know it. If something's very dense, what's going on with it? It is gonna be heavy, but why is it heavy?
It's all the way in the middle. I mean,
What do you mean? Go more.
like, it's heavy in the middle, but on the outside it's like, dull.
No, that part ruined it.
Isn't it, it has more particles, area, it's like, the more dense it is, the more particles it has, and the area you're talking about.
When something is more dense, it's got lots of matter in its volume. In other words, let's put this in science words. Density is right there. It is the amount of matter in a specific volume. I like to think of it though without science and just talk about how tightly packed that matter is. What does a very dense suitcase look like?
It's like packed to the brim.
Packed to the brim, sitting on it to close it. That's a very high density suitcase. What's a low density suitcase look like?
I have lots of room.
Lots of room. So like my suitcase when we go on vacation is very dense, packed with my entire wardrobe because I don't know what I'm gonna want to wear. My husband packs the right amount of underwear and a couple shirts and one pair of shoes and the right amount of socks, maybe one swimsuit where I have all of mine. So density can change depending on how tightly packed it is. Sorry. Do you guys remember the formula? You just remember that? Who said that? Whose lips moved? You did, you just memorized it? Oh, you cheated? Use your resources. That is exactly what I wanted to do. Guys, yeah, by cheating this year, cheat, but use your reference table to cheat. Do you guys all know where to find formulas? What page? Yep, front cover, middle left. If you haven't already looked, just make sure you know where to find it and fill in the box with the words density equals mass over volume. This one time at least, write it out. The rest of the times, how do you abbreviate this? Yeah, D equals M over V. So if you want to add that to the box, you're welcome to. You guys calculated density in 8th grade, probably a ton, I'm guessing. They probably said the mass is 10. The volume is 5. What's the density? Okay, 10, 5, density is 2. They might have made you put this, how would I find the mass of this block? Put it on a scale. Then you do length times width times height and you find the volume. So those were what you guys did with density in your previous science histories. This year's gonna be maybe we're gonna do that, but we're going to take it to the next step. Like I said, I have to 10th grade all your stuff up. They're gonna 10th grade density up. And now I might ask you, well, I know the density of this is 4 and the volume of this is, let's go with 7. What's its mass? If I know the density is 4 and the volume is 7, what's its mass? How comfortable do you guys feel with that? You figured it out, a few of you. So if I was to just throw this up there, what I say, density was 4, volume was 7, and now I'm asking you, what's the mass? Oh, does this look like something you guys are familiar with? What kind of math am I asking you to do here? Yeah, a little bit of baby algebra though. How many of you like get sick to your stomach just thinking about algebra? Okay, maybe a few of you. I do, and the thought of making sure you know how to do algebra really makes me sick. I don't know how to teach people to do math. So we use what's called the magic triangle. In that space right next to the box where you just wrote about density, can you draw this in, please? So you got some space there. I would make it so big enough so you can see this is how we're going to do density unless you're an algebra whiz. It's not it. So we're gonna fill it in. M always goes on top. That is the only thing about this that you have to memorize. M goes on top. It's easy to remember because M is most important. Things that are most important go on top. No, it's not most important, but M, most, top, all of that. Get it? So put the M on the top in your magic triangle. Other than that, we can use the magic triangle to calculate. If we know the density, then we could, and we're looking for the mass, we can find the mass, or if we want to calculate the volume, we can. You can also use it to calculate density. Here's how it works. If, let's say we're looking for mass, like I just kind of did in that last example, to find the mass, what you do is you cover up the variable you're looking for. So whichever one you want to know about, so in this case, I want to know about mass, I cover it up. And now what am I left with? Density and volume. And in math, when two variables are sitting right next to each other, what math do? You multiply that. So the formula for mass is sitting right there. It's density times volume. So I think you should probably have some more room right here. Do mass equals density times volume. All you got to do is cover up the variable you're looking for, and voila, there's the math you need to do. Let's do it for density, even though I know it's in your reference table, but if you wanted to do it anyway, cover up the D. What are you left with? Mass over volume. And in math, when you have one over the other, what math do? Divide. Mass divided by volume. So density equals mass over volume. And there's one left. So if you want to do volume, you cover up the V. And what's the formula? V equals M over D. Easy enough? Okay, so then you're gonna have to be able to do that. And then there's one major concept about density that I'm not sure you've ever even thought about. So here's, again, is that block of wood. So we have a block of wood. And what's density again?
The amount of matter in a specific volume.
Amount of matter in a specific volume, or how tightly packed the molecules are. So in this piece of wood, I don't know exactly what the density is, but the molecules are all packed throughout here. What happens if I cut this block in half? What happens to those molecules? There'll be two separate blocks, but how tightly packed will the molecules of wood be in each piece? They'll be the same. It doesn't matter if I cut it in half, or if I just take out one little chunk, or even just a sliver of this. How the atoms are arranged stays the same. The same is true for any object. So you could have a gold ring, a block of gold, or a statue of me made out of gold. Gold is gold. It doesn't matter where the gold is from, what shape it's in. How tightly packed those molecules are always the same. The same substance will always have the same density. And that is the first thing you do need to talk about, or make sure you get. It's specific. Gold will always have a density of 19.3 grams per centimeters cubed, no matter what. Because that's the property of gold. So for that gold statue of me, It's a beautiful statue of me, but it gets knocked over. And my head got broken off of the statue. What's the density of the head compared to the rest of my body? The same. Gold is gold. It doesn't matter if it's broken or cut in half or cut in a million pieces. It doesn't matter if it's cut into one big piece and one tiny fingertip. It is still the same substance, so it'll always have the same density. That's the second bullet you need. And I just want to prove this to you. That's the last thing we're gonna do. So we do have to calculate some densities. I probably should have had you grab a calculator, but just like yesterday, can I trust you to grab your phones and use those, or get up and grab a calculator? They're over by the fire blanket. So we're just going to do 2 math problems and then be done for the day, okay? So we got this block of gold. This block of gold apparently has a mass of 162 grams. They weighed it. It has a volume of 8.4. They measured length times width times height. Can you guys calculate the density, please? What'd you get? 19.3. Ooh, I think I said 19.2 earlier, didn't I? Did everybody round that to 19.3, not keep it as 19.2? Okay, so 162 divided by 8.4 should work out to 19.3. Now, somebody took a saw and cut that block into 2 identical pieces. So half of 100 and, what was it, 182, 162, half of 162 is 81, half of 8.4 is 4.2. Can you calculate the density of those, please? And it is 19.3 again. So because of the way math works and proportion works, even though it's half, they still work out to the same fraction of each other. So we're gonna call it quits there. You have no homework. You guys have 5 minutes because you guys finished ahead of my other classes. So if anybody has any questions or needs to show me old homeworks or needs anything from me, come on up.